Welcome to your last linear equations training video. This video is all about solving equations and inequalities when absolute values are involved. First, let's review what absolute value means. You're sitting here at 0, and your friend Bob is over at +3. He's a positive guy. But your friend Susie is a negative. She's sitting over here. Both of them are still 3 units away from you. So if you take 3 steps either direction, you get to one of your friends. Just different directions. This distance from 0 to a number is called the absolute value, and it is always positive. The negative sign just tells us what direction to go. So absolute value is always positive. It's a distance from 0 for any number. So if I set the absolute value, I have these long lines here. I have -3, the absolute value is 3, but that's also true of +3. Okay? If I said absolute value of -32.6, it would just be 32.6. So always positive. It's distance from 0. But if I have a variable involved, there's a couple of different options, right? So whatever I plug in here has to make a true statement. If I plug in -3, that would be a true statement, right? The absolute value of -3 is 3. But I could have also plugged in 3 for x, right? The absolute value of 3 is 3. So x has 2 possible answers for absolute value questions, with the exception of the absolute value of 0 is just 0. But what if there's more going on with this equation than just figuring out what numbers are 3 away? So let's say I have something looks like number 1 here. The process is very similar to equations, but we just have to do a specific setup first. So first, you want to get the absolute value alone. Let's go ahead and do that on number 1. I have 1. Second step, separate into 2 equations. So this 3w minus 1, in order to get the absolute value that gives you +1, it could be either at -1 or it could be at +1 because of what we just talked about with the distance from 0. So here's our 2 equations, and then we just solve them using our steps from linear equations where we get the variable alone. So at 0, w equals 0 here. Our other answer, we'll add 1 over, divide by 3, and our other option for w is 2/3. Those would both give me a true statement if I plug them in. When you look at problems like number 2, you especially want to remember the definition of absolute value, that it gives us a number's positive distance from 0. So this is giving me out a positive number. No matter what x value I plug in, it's going to give me a positive. Can that equal -8? Nope, cannot. So when you have a absolute value equaling a negative number, automatically there's no way to get that, no solution. What if instead of equal sign it was an inequality? Let's talk about that. So we're just looking at a simple one. The absolute value of x is less than 2. Let's look at our number line again. Here's 0, +2 is 2 units away, -2 is also 2 units away. Let's try plugging in the value for x into this inequality. Let's say x equals 0. Absolute value of 0. That is a true statement, so it worked right there. Okay, let's say x equals -1. The absolute value of -1 is 1, so 1 is less than 2. Yep, worked at -1. What if I try a -3? Plug that in. The absolute value, oh no, the absolute value of -3 is not less than 2, it is bigger than 2. And so we're going to want the values of x to be between -2 and 2. So we're not going to include that, right, because it's not an or equal to. I'm going to leave that open, and then we're going to connect our dots. So that looks a lot like something from the last video. It looks like an and inequality. So less than and, kind of rhymes. Or less than or equal to, same thing. We want something that's closer to 0 than 2 is. So we need everything in between -2 and 2. But what if it was going the other way? On this one, we have the absolute value of x is greater than 2, so farther away from 0 than 2 is. If I go 2 units away to the right, there's positive 2. 2 to the left, there's negative 2. If I try to plug in negative 3, let's see if it works this time. The absolute value of negative 3 is 3, which is greater than 2. Hallelujah! So over here, negative 3 worked. Positive 3 would also work. If I plug in negative 1 or 1, it's not going to work. So I just need the numbers that are at negative 2 or less and more than positive 2. That looks like an OR inequality. So I could rewrite it as x is less than negative 2 or x is greater than positive 2. Oh, I forgot to rewrite the other one. I would write it as negative 2 is less than x is less than positive 2. One way that I remember this and I tell students is can misspell the word greater, right? Greater. Absolute values, when they have a greater inequality, they're going to be an OR, and if they have a less than, it's going to be an AND. So again, we're going to solve this a lot like other inequalities, but first we need to set it up, just like we did with the equations. Looking at number 1, the absolute value is already alone, check. Number 2, we're going to set up a compound inequality this time. And so we're going to say, less than, that means and. So I'm going to have negative 5 in my expression, and then less than positive 5, right? So negative 5 goes on the left because it's smaller, and we're going to solve our and. Sometimes you'll see, by the way, students who will set it up like this. And they'll just write the and, kind of like we saw in the last video. And that is totally fine. You can do it that way as well. All right, negative 5. Let's go ahead and solve. Subtract 3, negative 8. And then positive 2, divide everything by 2, get negative 4, less than or equal to x, less than or equal to, 1. And of course, you can write that in interval notation, going from negative 4 to 1, included in square brackets. All right, let's try a greater than problem number 2. We're going to get the absolute value alone by adding 4 and we get greater than 7. And then we're going to set up our inequality, or compound inequality. So y minus 3, change the sign to go with the negative 1. And y minus 3 is greater than 7. So we're going in opposite directions, less than negative 7 and greater than positive 7. Solve, add 3, y is less than negative 4. Add 3 on this one, y is greater than 10. So our interval notation, because there's no equal to, we'll have parentheses, starting at negative infinity all the way to negative 4, and then 10 all the way to positive infinity, and our union sign in the middle. All right, on number 3, again, we have to remember the definition of absolute value will always give us a positive number. So if we have positive greater than negative 4, how often is a positive number? Any positive number greater than negative 4? All the time, because negative 4 is always negative. So this one is actually all real numbers. You don't have to set it up or solve it. Just figure out, well, that's always going to be true. Or you can write infinite solutions. Interval notation would be all the way from negative infinity to positive infinity. Alright, that's absolute value equations and inequalities. We have covered these 3 topics for linear equations tutor training. Go ahead and, if you haven't already, do that worksheet associated with these videos and then move on to your next videos. Well done.